All right, so let's talk about Venn diagrams. Venn diagrams show relationships among sets of objects, things, numbers, or whatever the case may be. They are made of a rectangle, which represents the universal set of objects that we're talking about, and inside it of circles that represent various subsets. What is a set then? A set is a collection of objects or numbers which in return are called elements. So let's look at how symbolic notation, set notation, and Venn diagrams can show the relationships between different types of sets. In set notation, the first thing we have is union. A union B. In set notation, that is represented by a sign which looks almost like a U. And as you remember from our symbolic notation, this is equivalent to using the V in symbolic notation. What it means is these are the elements that are contained in either the set A or the set B. In other words, they are all the elements that are in the circle for A and in the circle for B. They could be in either one of them, and they can also be in the overlapping part. Another sign is the flip downwards U, and that stands for A intersection B. It looks like a U flipped downwards and also corresponds to our V flipped around, or as we said earlier, like an A without the middle bar. That means intersection, and now we are talking about the elements that are only the ones that are in both the set A and the set B. In other words, we're talking about the ones that are in this overlapping section and nowhere else in that entire Venn diagram. And then you remember our squiggly line, which means not A, or when you talk about sets, you can also say complement of A. It's the same as in symbolic notation. And what it means is we're talking now about all the elements that are not part of the set A. If you see our circle for A, that represents all the elements that are part of it. Not A are all the ones that are outside. Doesn't matter whether they're part of B or not, but all the ones that are outside of A. This is what is represented by not A or complement of A. Let's look at an example together. Use the Venn diagram shown here on the right to determine if the following statements are true or false. First statement states, no trapezoids are parallelograms. Trapezoids are these objects here that are inside of the circle for trapezoids. And then we have all the ones that are parallelograms, and those are the ones in this circle. And we can see that those two circles don't overlap. They're separate from each other. There is not one element that is part of both of them, and therefore the statement saying that they aren't any is true. A Venn diagram that represents something when no element of one set is also an element of the other one usually looks like two circles that don't touch each other. The next statement says all rectangles are parallelograms. So let's look at all our rectangles, and those are the ones that are inside of this circle. And if we all now look at where all the parallelograms are, shading that circle, it's not really a circle, but you know what I mean. You see that the circle representing parallelograms covers all of the rectangles. All of the rectangles are inside of the parallelograms, and therefore this statement is also true. A Venn diagram that represents something where all elements of one set are elements of the other set usually looks like a larger circle or rounded shape here with a smaller one fully inside of it. Let's move on to the next one. Some rectangles are trapezoids. Now we got our rectangles here. You already know where they are. And we got our trapezoids over here. Do you see any overlap between these two circles? I don't. So in other words, this statement is false. For a statement where some elements of one set are part of another set, the Venn diagram would have to look like two circles that have at least a part where they overlap. Last but not least, some rectangles are rhombuses. If we look at our circle with rectangles, and then we look at our circle with rhombuses, we see that they indeed overlap. And in here, this part is where rectangles are also rhombuses. I'm sure you already know what shape we're actually talking about here, but just think about it. Doesn't matter for our purpose right now. Some rectangles are rhombuses. This statement is clearly true. And as we have said in the example above, for a statement with sum to be true, we need two circles that overlap, and that's indeed the case. All right, so for your summary, I want you to do two things. First, I want you to create two statements based on this Venn diagram about our quadrilaterals. One of those statements should be true, and the other statement should be false. And last but not least, I want you to just draw a little diagram, a little Venn diagram, one for a statement where all is correct, one for the statement where sum is correct, and one for a statement where none is correct. And if you think about it and just look at this page one more time, then you already know which ones I'm talking about. Very well. I will see you in class.